Okay, in this video, we're dealing with absolute inequalities. So I'm going to actually jump between, oops, wow, there we go, absolute inequalities. So there we go. We're going to do absolute inequalities. And I kind of showed my class this a previous day, and we'll see how this kind of works out. And I'll show it in not GeoGebra, but Desmos. Desmos is fantastic for this. So I'll show you part of it visually first, and well, I'll do the algebra first and then I'll show you the visual because it makes a lot more sense. So let's just take a look at this. So there's only one thing here is that minus. It's actually a plus that should be a minus. So right here, what I'm going to do is you can consider this one, and this one like terms. Think of it like an A. So I'm just going to solve this and put the absolute over on the right hand side and keep it over there, and any numbers, constants, I'm going to put on the left hand side. So what I'm going to do is going to say minus 4 minus 5 less than or equal to minus 6 3x plus 5. Oops. Right? And minus, well, again, another 3x plus, plus 5. Right? If I can make this a bit bigger. So what we then have here is this is going to be minus 9, right? And this is actually going to be less than equal to minus 7 3x plus 5. And I have, if I divide both sides by minus, I have to flip the sign. So 7 or 9 divided by 7, and I flip this, and there it actually is. So this is what we're looking for. So how does this and this come together, like this theory, right? Notice this case where you have the absolute greater than k, so a value. So this is just a constant, right? K for constant. And greater than, or which is less than the absolute. Well, you're going to have the or situation, right? And we'll see this in the visual. Notice that what we have here, and I'll show you exactly with using this, right? Using this equation right here, I'll show you using the absolute, or using Desmos, right? That's what we're interested in, and how it relates to this, because this one should be and. Okay, so I'm going to put that into Desmos. So here's Desmos, and I have to just change something here because I got it wrong. So this is minus x plus 5. So this has got to be 3x plus 5. So there we go. So notice what we got here. There, I can even put in the equation. Let me just move this over so you can see it. There's Desmos. There, you can see the equations. Right, so you can even see the points. There it is, and we'll actually calculate these 2 points: the x, the minus 2.095, and the minus 1.238. We'll be able to actually calculate that algebraically. We can see it in the graph because I actually have this right here. So if I took that away, that disappears. But you can actually put this kind of equation in right from the beginning. But notice what we have. We have everything shaded in between those 2 points. So this point and this point. What happens if I remove the equal? It becomes dotted. What does that mean? It doesn't include the points at the zeros. So those points at 0 are not included. So that's my minus 2 and point blah, 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 and minus 1 point blah, 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 right? So those wouldn't be included. What happens if I switched it around? Oh, there's the or situation. So it's either everything on the left or it's everything on the right, not including the points where the red line and the blue line intersect. What happens if I make it equal? Oh, now it's solid. So now we get to see why we have these two conditions, an AND connector or we have the OR connector. And it has to do with the inequality sign. So our case that we're dealing with is this one. So we can see that, okay, these are the values I should get. So let's work the algebra. We already got up to this point for the algebra. We know how we get 9 over 7 is greater than or equal to that expression. Great. So how do I deal with it from that point on? Well, we know that it's an and situation, and that would mean the following. We'd have in the middle 3x plus 5, which is going to be less than or equal to 9 over 7. And this has to be greater than or equal to minus 9 over 7, right? That's where it becomes negative, just as it says up here. Yep, there's the and, right? So really, this one's saying they split it like this, but they're actually saying this. So they could be a little more truthful here, because they're assuming the reader could be, clever enough to put it. And sometimes as readers, we're not that clever. And then thinking of it that way, right? So there we go. So again, now all I have to do for this is then subtract both sides by the 5. So how we operate with these just the same as anything else. So we could 9 over 7 minus 5, 3x, 9 over 7 minus 5, right? And again, I'm going to just put parentheses around put brackets around them, and I'm going to multiply everything by 1 over 3, because this will disappear. So I'm going to take this, and I really have 9 over 7 minus 5 multiplied by 1/3. And on this side, I have minus 9 over 7 minus 5 bracket times 1 over 3rd. Well, what you get is that's approximately equal to minus, put it into your calculator, minus 2.905, less than or equal to x, less than or equal to 1.286, I believe. And there you go, you're done. That's the solution. And you can graph the solution. Well, you already saw the graph of the solution. It's right here. That's the graph of the solution. And you see the green area is the shaded. That's your solution. So it's everything in between there. Done.